Hello friends, now we will discuss one university question on design of steel beam. This university question is for Anna University for the year May 2016. The steel beam span is 4 meters and it is laterally supported. Generally it is deriving lateral support by virtue of the floor slab or deck slab which is supported on the steel beam. It carries a total UDL of 40 kilonewton inclusive of self weight. We have to design an appropriate section. Using the steel of grade Fe410, this is the generally used section for structural steel construction. Fe410 means ultimate stress is 410 Newton per millimeter square and yield stress Fy is equal to 250 Newton per millimeter square unless otherwise specified. This Fe410 is mentioned means we have to take Fy is equal to 250 Newton per millimeter square. Now the design procedure involves assuming an approximate section and then checking it for 3 criteria. One is bending capacity, the other one is shear capacity, and the other one is deflection. Now we will first calculate the bending moment. Now total load is 40 kilonewton. That means bending moment is equal to WL by 8, 40 into 4 by 8, 20 kilonewton meter. Here this 40 kilonewton includes self weight also. If self weight is not included, we have to add another 1 kilonewton to 5 kilonewton depending upon the span of the girder or magnitude of the loads applied on the beam. Here self weight need not be added. It is already included. It is floor beam joist. It is already included. That has been mentioned. Now the bending moment so calculated due to the applied loads should be multiplied by 1.5. This is the load factor. This factor should be applied for the limit state design 1.5. Now the design bending moment is 30 kilonewton meter. Now we have to choose an approximate section. For choosing the approximate section, the formula for ZP, plastic modulus of section, is equal to M divided by F. F, as I told, we have to take 250 Newton per millimeter square. M is equal to 30 kilonewton meter. That means if you multiply by 10 power 6, you will get it in Newton millimeter. Now, Fy is equal to 250 and the material factor of safety is 1.1. In fact, here this 1.1 should appear 250 divided by 1.1. As a result of which 1.1 should appear in the numerator. This is a mistake. Anyhow, this is a rough work. This is just giving the range of plastic modulus of section required. This is M divided by Fy. Fy should be reduced by 1.1. It should not be increased by 1.1. That is the material safety factor. You have to divide this 250 by 1.1. So it will appear in the numerator. That is a mistake. This plastic modulus of section will be in the range of 125 centimeter cube. This is an approximate design. This will give the range. And we have chosen a section ISMB 175, which is giving the plastic modulus of section of 166 centimeter cube. This can be referred from the steel tables. Now we will proceed to the bending capacity check. Before checking for the bending capacity, we have to decide on the exact value of the allowable stress to be used in the design. It depends on various ratios, which depend on breadth of the flange, thickness of the flange, depth of the web, thickness of the web, etc. Now you can see here. This is the typical cross section of a rolled beam. BF is the breadth of the flange. Half of BF, that is B by 2, measured up to the center line of the beam. TF is the thickness of the flange. Thickness of the flange will not be measured at the end. Thickness of the flange will not be measured at the web also. It will be measured in between. That location is given in the steel table. This is the thickness of the flange. Bottom portion of the flange will be having a curvature. This thickness will be measured somewhere between the web and the edge. B by 2 is the overhanging portion of the flange. Now, H is the total depth of the section. ISMB 175 means the total depth of the section, top of the top flange to bottom of the bottom flange. If you measure, that is equal to 175, which is equal to the depth of the section. It is called as H or H1. Now, depth of the web. How the depth of the web is calculated? Out of the total height, you have to deduct this thickness of the flange, and you have to deduct this curved portion of the flange also. This is called throat thickness. You have to deduct thickness of the flange. You have to deduct this throat thickness, which is the curved portion. After deducting this thickness and also the throat thickness, and similarly, you have to deduct the thickness of the flange at bottom. You have to deduct the throat thickness at bottom also. The remaining distance is called D, depth of the web. TW is the thickness of the web. Now we will proceed to the main part. So these are all the parameters already described by means of the sketch. B by TF. B is the half of the flange width divided, that is overhanging portion of the flange divided by thickness of the flange. The ratio is coming to 45 by 8.6 is equal to 5.2. The limiting ratio, the critical ratio is 9.5 into 1. Generally, this factor will be 1. This 250 in the numerator will remain constant. This 250 in the denominator corresponds to Fy of the steel grade which is used. This steel Fy value will be 250 unless otherwise specified. If they are giving Fy is equal to 280, then you have to substitute 280 in the denominator. If they give Fy is equal to 300, you have to use 300 in the denominator, in which case this will be less than 1, and this value, critical value 9.5 will be slightly reduced. Here this is 1, this factor is 9.5, this critical ratio B by T is 5.2, less than 9.5, therefore flange is plastic. Now depth of the web is calculated, 175, total depth of the section minus 2 times the flange thickness minus 2 times the throat thickness. These values are given in the steel tables. Therefore, depth of the web is 137.8 mm. Thickness of the web, again from steel tables, 5.5 mm. D by T ratio, 37.8 divided by 5.5, 25. Here the critical ratio is 84 into 250 divided by Fy. It happens to be 1. So this is the critical ratio. It becomes 84. Here also D by T ratio is less than 84. That means the web is also plastic. Therefore, the section as a whole, it is plastic. When the section is plastic, you have to take Fy value is equal to 250 Newton per millimeter square without any reduction. And another points to be noted here. D by T ratio is equal to 25. This is less than 84 and also less than 67 also. 67 is another critical ratio for the web, which we have to remember. When this ratio D by T is less than 67, that means the web does not buckle. The shear stress value can be taken without any reduction. It shows that web is not buckling. It shows section is plastic. Formula for MD, the moment capacity, Fy into Zp. Fy, of course, material factor of safety should be taken 1.1. Fy divided by material factor of safety 1.1 into Zp 250 divided by 1.1. This is in Newton per millimeter square. Zp is equal to 166 centimeter cube. To convert this into millimeter cube, multiply this by 10 power 3. You will get this moment capacity in Newton millimeter. Then you divide this by 10 power 6. You will get the moment capacity in kilonewton meter, 37.7. This is higher than the design moment of 30 kilonewton meter. That means it has passed the check for bending capacity. The next check is for shear capacity. The shear force is equal to total load divided by 2. 40 by 2 is equal to 20 kilonewton. We have to apply the load factor in the limit state design. The load factor is 1.5. So the design shear is 30 kilonewton. Now we will calculate the shear capacity. The shear stress is equal to Fy by root 3. There is no reduction. There is no buckling of the web because D by T ratio is less than 67. There is no buckling of the web. Fy by root 3 is taken as such into H. That is full depth of the section, H into TW, that is thickness of the web. Of course, the material factor of safety should be taken, that is equal to 1.1. This is applied on Fy. This is equal to 250 by root 3 Newton per millimeter square. This is in millimeter. This again is in millimeter. So you are getting this in Newton. So to convert this into kilonewton, divide this by 10 power 3. It is coming to 126.2 kilonewton, greater than 30 kilonewton. Therefore, it has passed the check for shear capacity. Now we will check for deflection. The formula for deflection is 5 by 384 into W L cubed by EI. Here W is the total load. Since W is the total uniformly distributed load, here the term is L cubed. If it is UDL, then it will be L power 4. Here this is total load. Therefore, this term is L cubed. E is equal to Young's modulus 2 into 10 power 5 Newton per millimeter square. Span is equal to 4 meters, 4000 mm, L cubed. So 3 power 3. 40, the load, kilonewton. Convert this into Newton, multiply by 10 power 3. 5 by 384 divided by I, 1272 centimeter power 4. As per the steel tables, centimeter power 4 to millimeter power 4. Multiply this by 10 power 4. Ultimately, you are getting this deflection value as 13 millimeter. So, what is the limiting value of deflection? Limiting value of deflection is L by 300. That comes to 13.33 millimeter. The actual deflection 13 millimeter is less than L by 300. Therefore, it has passed the deflection check also. In case if any of these parameters, any of these checks, shear check or deflection check, if it is not fulfilled, you simply write, use the higher section. If it has not passed, you can write, we can use ISMB 200. We need not revise the entire calculation. Here it has passed all the tests. Therefore, ISMB 175 is the final design. In case if it fails any check, just increase the section to the next level. If ISMB 175 has not passed deflection check or shear check, increase the section to ISMB 200. Calculation need not be revised. One more second. Please visit my website https://rgnsite.wordpress.com. It contains blog materials on various structural engineering subjects, RCC design, steel design, structural engineering for diploma board examination, strength of materials, structural analysis part 1, structural analysis part 2, etc. In totality, it contains about 500 university questions and answers including this one, which we have discussed just now. It contains 500 university questions and answers and about approximately 800 one-word university questions and answers. The download is free. It includes the question which we have discussed just now also. This is my website address. Please visit. The download is free. rgnsite.wordpress.com. Thank you.